Hello everyone, my name is Ibaphylla Khongsit and I am from the Physics Department of Assam Don Bosco University. In this video, I am going to talk about the BiotSavart law. But before we go into the topic, we know that BiotSavart law deals with the magnetic field. So let us recall some of the basic things of the magnetic field. So what is the magnetic field? It is the region around a current carrying conductor when the magnetic effects can be experienced. Usually, the moving charge or the electric current is the source of the magnetic field. The magnitude and direction of the magnetic field is represented by the magnetic flux density capital B, and its unit is given in Tesla. Now, BiotSavart's law. This law tells us the relation of the strength of the magnetic field produced by a current or creates by a current. According to this law, the magnitude of the magnetic field at any point depends directly upon the current element, sine of angle theta, and inversely proportional to the square of the distance between the current element and the point P where the magnetic field is to be calculated. Now from figure 1, let us consider a wire conductor XY in which the current I is flowing in this direction. Along this path of the wire, let us consider a small element dl, and since the current I is flowing in this path, therefore this element dl is known as the current element, which is represented by IDL. Now, let us consider a point P, this one, where the magnetic field is to be calculated. The magnetic field in this point P is very small, which is why we represented it as dB. And let R be the distance of the point P from the current element IDL, and let theta be the angle between DL and R. So according to this law, the magnetic field dB is directly proportional to the current element IDL. That is, larger the current or larger the length, larger will be the magnetic field. Similarly, the magnetic field depends directly on the angle theta and inversely proportional to the square of the distance. That is, larger the distance, smaller will be the magnetic field, or smaller the distance, larger will be the magnetic field. Then, according to BiotSavart's law, the magnitude of the magnetic field dB at the point P due to this small current element is given by dB is directly proportional to IDL sin theta divided by R square, or dB is equals to KIDL sin theta divided by R square. Here, K is a constant of proportionality. Its SI unit in free space is given by K is equals to mu naught by 4 pi, where mu naught is the absolute permeability of free space. Therefore, K is given by equals to 4 pi into 10 to the power minus 7 inverse ampere Tesla meter. Therefore, the magnitude of the magnetic field dB is equals to mu naught by 4 pi IDL sin theta divided by R square. Equation 1 is known as the BiotSavart's law, which gives us the magnitude of the magnetic field at the point P due to the current element IDL. BiotSavart's law holds strictly only for steady or constant current. Now, in vector form, the BiotSavart's law is represented by dB is equals to mu naught by 4 pi IDL cross R divided by R cube. Since BiotSavart's law is analogous to the Coulomb's law in electrostatics, we can observe that just in the case of Coulomb's law, the charge Q is the source of electrostatic field. Similarly, in BiotSavart's law, the source of the magnetic field is the current element. Now we discuss about the direction of B. The directions of the magnetic field dB is perpendicular to the plane of the containing DL and R. By using the right hand rule for the cross product, It is observed that the direction of the field is directed inward. Now the magnetic field due to the whole conductor. Equation 2 above gives the magnetic field at the point P due to the small current element IDL. Therefore, the total magnetic field at a point P is found by summing or integrating over all current elements, which is given by B is equals to integrations of dB is equals to integration over mu naught by 4 pi I dl cross r divided by r cube, where the integration is taken over the entire conductor in which the current I flows. Important points about BiotSavart's law. Point number 1. This law is also called Laplace law and inverse square law. Point number 2. This law cannot be tested directly. This is because it is not possible to have a current carrying conductor of length dl. Point number 3. A current element is the product of current I and length of very small segment dl of current carrying conductor. The current element is a vector. Its direction is tangent to the element and acts in the direction of a current flow in the conductor. Point number 4. A current element contributes no magnetic fields to the point that lies along the line of the current element. This means that the current element IDL causes no magnetic field at a point along a line that is tangent to it. Point number 5. The value of the magnetic field dB is maximum when the angle theta is equals to 90 degree, and it is minimum when the angle theta is equals to 0 degree and 180 degree. So, BiotSavart's law can be used to find the magnetic field of various shapes of a current carrying conductor. I hope with this video you will learn something about the BiotSavart's law. Thank you.